in this example, I'm giving you two vectors and the angle between them, okay? First of all, I've got vector v has magnitude of 22, and vector w has a magnitude of 15. And the question then is, can you find the vector v plus w if the angle between them is 40 degrees? All right, so first of all, let's go through and sketch in v plus w. Now, I said v plus w is going to be the diagonal of the parallelogram containing sides v and w. Okay, so what I would do is sketch in the rest of the parallelogram, assuming I can draw a line that's straight and roughly parallel to v. Not bad. And then another one that's roughly parallel to w. Okay, something like that. Now that might be a little bit off. I think that w is a little bit off. Okay, something like that. So, we know that in parallelograms, opposite sides have equal length, and opposite angle, where am I going? Opposite angles have equal length, okay, or equal length, equal magnitude. Equal magnitude? Equal measure. Oh my goodness, they're congruent. Anyway, so when I sketch in the diagonal that goes v plus w, so you go down v and then across w, you get the diagonal here that splits down the middle. I guess they both technically do, but you get the one going down to the right here, okay? And that's going to be v plus w. So, our goal is to find the length of that side of the triangle, essentially. And so, all I really know is that this angle up here is 40 degrees. But what's interesting about parallelograms is that adjacent angles are supplementary. Now, that may not be obvious at first glance, but look at this for a moment. This angle up here is 40 degrees. If it is split into two parts, now I don't know that it's not gonna necessarily be bisected. These could be 20 and 20, they could be 10 and 30, they could be 15 and 25. They just have to add up to 40, the two angles up there, okay, those two angles. And so I don't know that they're the same, but I know that they add up to 40. But what's interesting is we also have parallel lines cut by a transversal, which means that the angle up on the top left is congruent to the angle on the bottom right over here, the opposite, oops, sorry, not that one. Opposite interior angles, that one right there. Right, opposite interior angles of the parallel lines are going to be congruent. And so this one up here is congruent to itself. And so what you end up with is the sum of those two angles is going to be 40, right? The sum of the two up here are 40, so the sum of these two with the one arc and the two arcs are going to be 40 as well. And so if you use the angle sum formula, I know if I'm going to call this, maybe I'll call this angle A up here and angle B down here, then in my triangle, we'll call that one angle C. I'm just giving you some sort of variables to reference here. Then I know that A plus B plus C is 180. It's the angle sum formula for a triangle. And A and B together make up 40 degrees, right? Because B is also this angle up here. So A and B together make up the 40-degree angle between the two vectors. And so that means that that angle is supplementary to angle C, because together the 40 and C will make up 180. Okay, so C is going to be the 180 minus the 40, which is a 140-degree angle. All right, so that's this angle down here. So now I know two sides and the included angle of a triangle, right? So I have this triangle on the bottom left. I know two sides, they're 22 and 15, and the included angle is 140. And so those three pieces of information allow me to find the opposite side using the law of cosines, right? So if you think about the law of cosines, and I'm going to use, let's see, I'm going to use this angle C here, because that's the one I know. So I know that little c, remember the law of cosine says little c equals a squared plus b squared minus 2ab times the cosine of big C, right? That would be one of our law of cosines using angle big C. Well, the AB and little c are all just lengths of these vectors. Okay, so little c is the side opposite big C. So little c is actually the magnitude of v plus w squared, interestingly. Little a, well, it doesn't matter which one, it's arbitrary, but I'll go with vector w there because it's opposite what I labeled as angle A. Doesn't matter. So vector w squared, the magnitude of w squared is side A. Side B would be the magnitude of v, so I want magnitude of v squared minus 2. Now a and b, that's going to be magnitude of w times magnitude of v times the cosine of 140. All right? So I've essentially used the law of cosines, but now I'm using the magnitudes of the corresponding vectors as the sides of the triangle. Okay? Then I plug in everything I know. The only thing I don't know is the left side here, so I'm going to have to solve for that eventually. So I have the magnitude of v plus w squared is equal to, well, w was, remember, 15, magnitude of w. So 15 squared, magnitude of v is 22, square that, minus 2 times 15 times 22 times the cosine of 140. Okay, so we're going to plug all that into the calculator. I can do that all in one shot. So I get 15 squared plus 22 squared minus 2 times 15 times 22 times the cosine of 140. And that gives me a value approximately 1,214.589, and there's a few other decimals in there I'm not too worried about. And then I want to take the square root of that to get my answer, right? Because over here I have the magnitude squared. I'm not interested in the square of it. I'm interested in the value itself. So it'd be the square root, or approximately the square root of that answer. And of course, this is going to be an approximation. We're going to round this off, but I'm going to try to keep all the decimals in my calculator when I do this. So I'm going to hit square root and then the answer, second answer. So it should look something like that. And I get about 34.9 roughly. Now, everything is rounded to the nearest whole number here, so I'd probably round that to the nearest whole number, 35 degree, or 35 is the magnitude, so roughly 35. Now, I didn't measure this in feet or centimeters or anything like that. We could have put units on these, we didn't need to, but that's going to be the magnitude of the diagonal, or the sum of the two vectors.